Hello everyone, welcome to another video. If you are new to this channel, please remember to subscribe, like, share, and comment. Now what we're going to look on in this video is transposition of formulae. Now you may ask, what is a formula? A formula is a general equation showing the connection between two or more related quantities. For example, A equal pi r squared is a formula for the area of a circle in terms of radius r. A is said to be the subject of the formula, right? So this formula that we have here, which is A equal pi r squared, A is the subject. All right. Example 2. P is equal to 2 times L plus B is the formula for the perimeter of a rectangle in terms of its length L and its breadth B. P is said to be the subject of the formula, right? So when we have a single letter equaling something, then that single letter is referred to as the subject. Now, changing the subject of a formula or transposing the formula refers to the process where the formula is rearranged so that another given symbol becomes the subject. In transposing a formula, all the rules are obeyed as in the solution of equations. However, we now have more than one symbol to deal with. It should be noted that when a symbol is the subject of a particular formula, 1, it should satisfy these conditions. 1, it is usually on the left-hand side of the formula. It is in the numerator. 3, its power is 1. And its coefficient is also 1, right? Now, we have different cases, and we're going to look on case number 1. Case number 1 has to do with symbol connected by a plus sign, right? So when a symbol is added to one side of a formula, it can be transferred to the other side of the formula by subtracting it from both sides of the formula. For example, transpose V equal U plus T for U. What this is saying that we want to make U the subject of the formula, right? So the first thing that you're going to do is to rewrite your question. And that's how you would rewrite it. So V is equal to U plus T. Now we want to make U the subject, meaning that we want U to equal to something. So we need to look at what is happening to the U. Now in this case, T is being added to the U. So we can transfer that T to the other side of the formula, right? By subtracting T from both sides, right? And this is how you write that step. So you would have V minus T equal U plus T minus T. So we subtract T from both sides. And note I highlight it in red there. That is what I have been added to this line. By subtracting T from both sides now, what you realize that positive T minus T, that will give us 0. So it will just leave us with U on the right. And on the left, we will have V minus T. Now, U is the subject. But remember, we normally put the subject on the left. So what you're going to do is to rewrite that line to say that U is equal to V minus T. And you're finished there. All right. Now I have 2 more examples and let's look at them really quick. So here, a second example says make Q the subject of the formula R equal Q plus P. So first thing, we write our question. And we know that R is equal to Q plus P, right? We look at what is happening to the Q because Q is we want to be the subject. So this Q P is added to Q. So what we can do to transfer the P to the other side is to subtract P from both sides. Right? So we can subtract P. So we're going to rewrite our problem first, which is to say that we have R is equal to Q plus P. And then we show that we are subtracting P from both sides. So we're going to minus P from this side. And whatever we do to one side, we have to do it to both. And we're going to minus P from this side as well. Clearly now, positive P minus P, that's going to give us 0. So what we're left back with on the right is just Q. And on the left, we have R minus P. Now, we normally write the subject on the left. So you just rewrite this line to say, therefore, Q is equal to R minus P. And you're finished. Let's look at the third one. Transpose capital R plus lowercase e equal lowercase r for E. So in this case, we want to make E the subject. So the first thing that we need to do is to rewrite our question, right? So we know that capital R plus E is equal to common R. Now we know that capital R is being added to the E. So if we want to transfer it to the other side, we need to subtract capital R from both sides. So we first rewrite our problem, which is to say capital R plus E is equal to common R. And then we show that we are subtracting capital R from both sides. So we put minus capital R minus capital R. Note there that we show that, and here R minus R, that's going to give us 0. So what we left back with here on the right is E is going to equal to R minus capital R. E is the subject, and we're finished. Now case 2 has to do with symbols connected by a minus sign. When a symbol is subtracted from one side of a formula, it can be transferred to the other side of the formula by adding it to both sides of the formula. For example, transpose V equal U minus T for U. So we first rewrite our question, right? And we'll have V equal to U minus T. Then we look at what we want to be the subject. We want U to be the subject. We look at what is happening to the B, to the U. We note that T is being subtracted from U, and we want to transfer that T to the other side of the formula. So what we can do is to add T to both sides, right? And this is how you would do it. So we add T to both sides. By adding T to both sides, you note that on the right, minus T plus T, that's going to give us 0. So that's going to leave us with U. And on the left, we will have V plus T. All you need to do here is to just rewrite U, which is the subject, on the left-hand side. And you will see, therefore, U is equal to V plus T, and you are finished. Alright? We have 2 more examples here, and let me walk you through them very quickly. So this one says, make Q the subject of the formula R equal Q minus P. So we have R is equal to Q minus P, right? And we know we want to make Q the subject. We realize that P is being subtracted, right? So in order to transfer this P to the other side of the formula, we can add P to both sides, right? So we're going to rewrite this, which is to say R is equal to Q minus P. And then we show that we are adding P to both sides. So we're adding P to this side, and we're also adding P to this side. By adding P to both sides now, minus P plus P, that's 0. So what we're left back with here is just Q on the right hand side, and on the left we have R plus P. Now all you need to do is to just rewrite this statement, and you're finished. So therefore, we say that Q is equal to R plus P. And that's how you make Q the subject there. For the last one now, transpose capital R minus E equal R for E. So first, write back our question, which is to say capital R minus lowercase e is equal to lowercase r. We want to make E the subject, right? Now, if we want to make E the subject here, we note that E is being a negative E here, right? So what we can do, we can add E to both sides, right? By adding E to both sides, we are getting the E to be a positive E. So what we would have here is to say that R minus E plus E is equal to R plus E. Now note that minus E plus E here will give us 0. So on the left hand side, we left back with uppercase R is equal to lowercase r plus lowercase e. Right? Now remember, our objective is to make E the subject. That means we want E to equal to something. So when we look at this E, we know that R is being added to it. So in order to transfer the R to the other side, we are going to do the opposite of adding R, which is to subtract R from both sides. So we can subtract R from this side, and we can also subtract lowercase r from this side. By doing that, here you will note that positive R minus R, that gives us 0, so what we left back with is E. And here we have uppercase R minus R is equal to E. All you need to do is to rewrite. So you say, therefore, lowercase e is equal to uppercase R minus lowercase r, and you are finished. Alright? So that's how you would do case 2. Let's look at case 3. So case 3 has to do with symbol connected as a product. When a symbol is connected to one side of the formula as a product, it can be transferred to the other side of the formula by dividing both sides of the formula by it. Example, transpose V equal RW for R. First thing that you need to do is to rewrite the question, right? That's how you would rewrite it. Then we look at what we want to be the subject. We want R to be the subject. We look at what is happening to the R. We know that the R is being multiplied by W. We must do the opposite of multiplying by W, which is to divide both sides by W, and that will allow us to transfer the W to the other side of the equation. So you write back what you have and just divide both sides by W, and you will end up with V over W is equal to RW over W. Note that here, RW over W, the W will cancel out, so you will now have R by itself. So here, R is the subject, but you're going to rewrite this statement to make R be on the left hand side, right? So we say, hence, R is now the subject of the formula, and when we rewrite it, you will end up with R equal to V over W, right? We have 2 more examples that I'm going to walk you through really quick, and then we're finished with this one. So we say transpose P equal HQG for G, right? So we are given the formula P is equal to HQG. We want to make G the subject. What you need to do, look at what is happening to the G. Realize that there's a product here. HQ is multiplying the G. To transfer HQ to the other side of the formula, we're going to divide both sides by HQ. By doing that, you know that HQ here will cancel out HQ in the denominator. So what we're left back with here is to G is equal to P all divided by HQ. All I need to do is to just rewrite so that G is on the left hand side. So therefore, G is equal to P all over HQ. And you're finished there. For the last one, it says transpose V equal RW for W. So we know that V here is equal to RW. This time around, we want to make W the subject. So W is being multiplied by R. So in order to transfer this R to the other side, we just do the opposite, which is to divide both sides by R. Dividing both sides by R, clearly here R will cancel out R. So what we have on the right is W, and on the left we have V all over R. And to finish, we just rewrite the statement so that W is on the left. So we say, therefore, W is equal to V all over R. And we are finished. So that is how you deal with formula that include products. All right. Let's look at case number 4. So now case number 4 has to do with formula that includes quotient, right? So we see when a symbol is connected to one side of a formula as a quotient, it can be transferred to the other side of the formula by multiplying both sides of the formula by it. So example, we have transpose I equal V over R for V. So in other words, we want to make V the subject. In that case, I is the subject, right? So you can clearly see that I here is the subject, but we want V equaling something. Note that this V is being divided by R. So in order to transfer it to the other side of the formula, we're going to do the opposite of dividing by R, which is to multiply both sides by R. And if you multiply both sides by R, this is what it will look like. So you will now have I times R equal V over R times R, right? By multiplying both sides by R here, clearly you will realize that the R on the right will cancel out. So what you will end up with is IR is equal to V. In order to finish this question, you will just rewrite that statement so that the V is on the left. If you rewrite it, that's what you will end up with. V is equal to IR. And clearly here you can see that V is now the subject. Now let's look at example 2. Now example 2, here we're asked to transpose F equal V over 2 pi R for V. So in other words, we want to make V the subject, right? So we rewrite our problem to say F is equal to V all over 2 pi R, right? So here, if we want V by itself, we look at what is happening to the V. The V is being divided by 2 pi R. So in order to get rid of the fraction here, we can multiply both sides by 2 pi R, right? So we do the opposite, which is to multiply both sides here by 2 pi R. I'm going to multiply this side as well by 2 pi R. So note here that 2 pi R will cancel out 2 pi R. So on the right, what we're left back with is just V. And on the left, we will end up with 2 pi R F, right? All you need to do is to just rewrite. So therefore, V is equal to 2 pi R F. And V is now the subject, right? So we finished there. But this one now, transpose F equal V over 2 pi R for R. So we know that we have F is equal to V over 2 pi R, right? There are several ways of doing this, but one way of doing this, we know that the subject that we want is in the denominator. We know that the subject cannot be in the denominator. It should be in the numerator. So again, we could multiply both sides by 2 pi R. And that will allow us to get the R in the numerator. So let's do that. So we're going to multiply this side by 2 pi R. And we're also going to multiply this side by 2 pi R. By multiplying both sides by 2 pi R will cancel 2 pi R here. And on the right, we're left back with v. And the left will end up with 2 pi r f, right? Now remember, what do we want to be the subject? We want r to be the subject. So at this time, we're going to look at what is happening to the r. This r is being multiplied by 2 pi f. Now if we want to transpose 2 pi f to the other side of the formula, we do the opposite of multiplying by 2 pi f, which is to divide both sides by 2 pi f. And whatever we do to one side, we have to do it to both sides. We have to divide this side by 2 pi f as well. By dividing, note here, 2 will cancel 2, pi will cancel pi, and f will cancel f. So what we're left back with here is just r is equal to v all over 2 pi f. And we're finished. R is now the subject of this formula. Okay? Thank you very much for watching, and I hope that you will enjoy the rest of your day.